All right, so 2.7, solving equations in one variable. All right, so we did some stuff like this a little bit in Algebra 2, I'm pretty sure. I think, however, that these boots are really loud. I think however, that we might have done it while we were quarantined last year, and so I don't know how much y'all like remember, understood, whatever. So I'll try to like explain it as best as I can. But with these problems, we want to remember that just because we get a solution, it doesn't mean that it's actually a solution. We might have, on occasion, extraneous solutions. So basically, once you find your solutions, you want to check to see if they're extraneous by plugging the answer back into the problem and seeing if it's true or not. Basically, if it gives you a true statement. So these are basically solutions that are not actually solutions of the original equation. And just for reference, okay, rational equations, because this is when you have rational equations is when you're going to potentially have an extraneous solution, is something that's written in the form f of x over g of x is equal to 0. Okay, obviously it might be equal to something, but you could always move it over and set the whole thing equal to 0. But basically, you have something over something. Typically, it's a function over a function, but because if it's just over a number, shouldn't really have that happen. But that's why I have unlined paper. Let's see. What? Oh. Let's see. See if there's any other note things I want to write before we do an example. Not really. All right, well, let's go ahead then and look at number 2. These ones, some of them are just like plug and chug, and you just go with it. Like, because I do the flipped classroom for Algebra 2, so like it kind of worked out because I was just gonna have to like do everything in one day, which for that particular section it wouldn't have mattered. But I just like wrote their notes out for them for that one section, and then I was gonna go ahead and like I try to give them like a day in advance so that they can like get ahead if they need to or whatever. Well, the next section, because I didn't have my camera or anything at home, so the next section is synthetic division, and I was like, yep, nope, not going to just write that out. We're just going to talk about that in class. I was like, not even going to try, because the first section is really easy because it's just exponents, and I'm like, okay, you should have seen that multiple times by this point in your math career, but yeah, I was like, okay, yeah, synthetic division not happening, not in person. Last week, when we were out. Yeah, well, that's what they said. Like, they sent out, they were like, you can do, like, virtual learning for a week. And I was like, I don't have my stuff. So I was like, if I don't have mine, they probably don't have theirs. So I have a copy of some different books at home, but I don't have a pre-cal book. I literally couldn't do anything for y'all last week. I mean, without actually coming to school, and that wasn't going to happen. So I was just like, just enjoy the week off. Alright, so with these problems, a lot of times you're going to have something that looks like this. You may have one where you have, like, fractions, if you will, on both sides. So do you guys remember how to solve this? I wouldn't. I wouldn't do that either. What by x? The whole thing. Yep. Okay, I want to do that because I want to get rid of my fractions. We all say we hate fractions. I want to get rid of them. So, well, most people hate fractions and they do not appreciate when I give them fractions. So, the good way to get rid of them is to multiply by whatever the denominator is for the whole thing. So, that means I'm going to end up with x squared. And then now I can do what? You could do, like, completing the square would be fine. If you wanted to, that would work. Yeah, I was going to say, it really depends. I mean, you can try because you're going to have 15, my first thought is to move it over because most people don't like completing the square. And typically if I say to complete the square, people don't. So, but I mean, if you did it that way, that would be an acceptable way to do it. Yeah, in technicality, you just basically, yeah, as long as you can get the factors of it, it doesn't matter. I just don't complete the square because typically it's extra work unless it's an easy one like 2. I mean, completing the square for 2 is pretty easy. But so we said the factors are 3 and 5. Which one's positive? Which one's negative? Okay, so x plus 5, x minus 3. And then what are my x values? X equals negative 5, x equals 3. Okay, so we need to check them to verify that they work. Okay, it should, but we just need to make sure. So I'm going to basically just go in through and plug in. So negative 5 plus 2 is equal to 15 over negative 5. So this is negative 3 is equal to negative 3. So we know that one works. And then 3 plus 2 is equal to 15 over 3. So 5 is equal to 5, and that one also works. So in this case, they both happen to work. But let's say we have something that's a little harder, like 6. So this one is 3 over x minus 1 plus 2 over x is equal to 8. Yeah. Okay, that would work. Are we just going to do, you just want to do it on the left? This one, it really doesn't matter. Okay, the reason, I'm just going to go ahead and tell you, the reason this one doesn't matter if we just do it on the left is because we don't have, like, once we get a common denominator over here, we can combine these things, and then we can just multiply by the denominator over here and basically get rid of it that way. So that's why it doesn't matter. I mean, and sometimes with these other ones, it'll work that way. Like in technicality, we multiplied to get a common denominator here. But, I mean, if we had done x over x, we didn't need to do that. But with ones like this, common denominator is the easiest. So how would I find the common denominator for these ones? Okay, so I'm multiplying 2 over x by x minus 1 over x minus 1. And what about this one? Multiply by x over x. Okay, because I have an x here and I have an x minus 1. Just multiplying by x minus 1 isn't going to give me the same thing for both of them, so I need to make sure that I do something that's going to actually give me a common denominator. So let's do the denominator first. So what do I have on the bottom? X squared minus x. And then on top, and then that's equal to 8. Okay, so 5x minus 2. I'm going to go ahead and multiply by this denominator just so I don't have to keep worrying about it. So this is going to give me 8x squared minus 8x. So then I need to get everything on one side. I don't care which direction you want to go with it, but you want to move everything to the left or the right? Move to the right. So what does that give me? And then is this something that I can factor? Okay, so with 16, my options are 4 and 4, 2 and 2, and 2 and 2. So there's really no way that I can get it because I could do 4 and 4 is 8, 8 and 2 is 10, 16 and 1 is 15. So no, there's no way that that's going to give me anything. So what should I do instead? No. Quadratic formula, so what is that going to give me to put it in? $13 plus or minus. Okay, b squared, so that's 169. Okay, so I'll just write it underneath just to save space. So you said this is 64. So this is minus 64, and this is 16. So then what does that give me inside here? And then is there anything I can take out of here? Everybody agree? Okay. Just as a refresher in case this comes up, if this, let's just say this was a 12 instead of a 13, can I take a 4 out of the top and bottom? It was, well, 14, 12, anything. Yeah, there would have to be something outside the radical. So let's say if this was a 12, and then we have 16 here, I'd have to have like a 4 or something here to pull out a 4, because you have to pull it out of both pieces of the top and then factor it out of the top and bottom. Okay? Hopefully we'll get one that kind of comes up like that, but that's just a really common mistake, so I don't want like that to be something that we do, like trying to get rid of something. Alright, well this is going to be exciting. Yeah. Yeah, so basically, like, normally our factoring is nice and it doesn't have a number out front, but if it does, you have to multiply. The arch method, like, a long time ago. But yeah, I just do it. I just always just say it. I just don't even think about, like, writing out. A lot of people actually draw the thing there to remember what they're dealing with, and then you have to get factors of that give you the negative 13. Alright, so we really need to check this and make sure that this works. With a problem like this, I will give you permission to do it in your calculator. Okay, to get this number as like a decimal. Okay, to plug it in, because I really don't think you want to be like multiplying and dividing by the radical of 105. So you would need to find 13 plus the square root of 105 over 16, and 13 minus the square root of 105 over 16. Okay, so find those two as a decimal, and then use that number to plug it in to check it. So somebody can tell me what this is, and then we'll... Maybe it'll come out to be nice, I don't know. Probably not, though. Okay, so we'll call it 1.45. We'll call it 1.45, and then how about the other one? 0.17. Alright, and then you're going to plug it into the original, so not this modified one. So 3 over 1.45 minus 1 plus 2 over 1.45 is equal to 8. So figure out if that's true. I hate problems that don't come out even. Like, that really drives me crazy. We might just call that true. You said it's what, 8.0 something? I don't actually have the answer to that one handy, so I'm going to have to look it up and see. How about the other one with the 0.17? I don't know. I have to look and see what they're calling it. This one is 8.15? Yeah, so they're going to call both of them as that they work. Okay, so we'll just make a general rule that if the whole number is like basically that, if you have a weird one, then you can say that they both are. Yeah. Basically go with the whole number. That's just going to be the easiest way. Hopefully, I mean, I'm going to try not to give you like super weird ones. Like, we'll probably just have a quiz on these two sections. I think we'll probably at least do a little bit with 2.8, but and then we'll be back to trig, I think, in chapter 3. So we'll probably have like a quiz on these two, and then not have a test until, so that you probably won't actually be tested on this. You'll probably just be quizzed on this. So I'll try not to give you ones that are like super weird or anything. Like your sine, cosine, and tangent stuff.
Oh, we're learning about trig.
That's exciting. That would just be fun to me, to like figure that stuff out. I need more green paper. Hence why you busted your head open. And didn't care. I love that problem 8 is literally the same thing as problem 2 in the book. They're literally the exact same problem. The instructions literally for 1 through 6 were solve the equation algebraically, support your answer numerically, and identify any extraneous solutions. For 7 through 12, it solve the equation algebraically and graphically, check for extraneous solutions. We're not doing the and graphically part. It's just like, if you can do it by hand, there's really no point in doing it on a calculator. Let's see. I guess let's look at 10 as another example. X plus 6 over x is equal to -7. Actually, with this one, let's try it, like, take a couple minutes and try it on your own first, and then we'll go over it. Do they make you wear, like, tennis shoes? Yeah, I know you can't wear, like... That's very true. I didn't even get to drive on the interstate and behind the wheel because I drove to Louisiana, and they decided that if I had done that, I didn't need to do behind the wheel driving on the interstate. So I was like, okay, well, that's exciting. I didn't do that either. That's exciting. Yeah, we had a girl who the instructor actually had to use the brake. And that's like a pretty much automatic you don't pass. Yeah, well, we did it with a different one, and they were like, if I have to use this, it's not good. Like, she straight up almost ran a red light with traffic coming. I was so scared. Sometimes I wish there was a brake when other people are driving me, but yeah, no, it was slightly terrifying. I was like, thank you, Lord, that I'm almost home. Like, it's also a huge no-no to pull through and behind the wheel. It's actually illegal to pull through a parking space. Fun fact. Yeah, just to pull through. He made you pull through? Oh, yeah. Ours was like, I mean, they claim it's going to be bad, but then, like, my instructor was like, yeah, I really don't care. She's like, just pull through. All right, did you get an answer? Wait, you got what? Everybody agree? Anybody disagree? Yeah. So basically, just multiply the whole thing by x. Move everything to one side. It really doesn't matter, but I like my stuff to be positive, so I moved it over to the left. And then factor it. Because the one time you don't check it, there's going to be an extraneous solution. Sure. Let's see. Yes. Alright, we're going to do one more, and then I'll give you guys a couple to start on, and then we'll pick this stuff up tomorrow again. 4x over x plus 4 plus 3 over x minus 1 is equal to 15 over x squared plus 3x minus 4. By working out perfectly, what do you mean? So, this is x plus 4, x minus 1, k over here. So that is, you can rewrite that to be that. So then what are you guys saying I need to do? Multiply the top. So you're canceling the denominators completely. Okay, yeah. So basically, just so we see what's technically going on here, okay, we're officially multiplying this whole thing by x plus 4 times x minus 1, okay, because that would give us a common denominator, or it would cancel everything out that we're going to have. So yes, 4x is going to be multiplied by x minus 1, and then plus 3 times x plus 4. And then this stuff cancels, leaving me with 15. Okay, and then you'll want to simplify everything so you can move that 15 over, and then simplify everything like all in one step if you want. So this would be 4x squared, 4x squared minus x minus 3 is equal to 0, and then I need to factor, if possible. So what does this factor into? What factors of 12 give you negative 1? They were nice and gave them to you right here. So then now I need to pull out, well, what you were saying though wasn't technically correct. Because you have to pull out, now you have to do the GCF. Because it sounded like, the way it sounded like was that you were like telling me what was in the parentheses, which technically wasn't right. Which maybe that's not what you meant, but that's what it sounded like. That's why I said no. GCF, greatest common factor. You want to pull out the greatest common factor of each piece. So basically I'm going to look at these pieces here. Okay, this is kind of a review because we haven't done a lot with the arch method, but you'll see that more with this section. So basically I'm going to pull out the biggest thing from these ones, which is 4x, leaving me with x minus 1, and then this one. Okay, so then this gives me, okay, the stuff inside has to match. If these don't match, you've done something wrong, okay? So then what's left outside goes together. So 4x plus 3 and x minus 1 is equal to 0. I don't know if this will help, but I want to see if I can focus it in a little better. Might just be the marker. A little bit. And so then what do I get for my x values? Okay, now what? It's all the way up here. I'll slide it down in just a second. Well, kind of have to, but there we go. So you can do this with, you can do it with your calculator if you want. Change it to 0.75 to actually figure it out. Okay, if you want to do this on your calculator, that's fine. If we don't want to work it out, I can just tell you what it comes out to be. Okay, this side is going to be negative 240 is equal to negative 240. Okay, but like I said, if you wanted to use your calculator to do that, you still need to set it up and show me that you're checking it, but then you can use your calculator to actually solve it if you want, just to save you time. So we checked that one. We need to check 1. So we're going to have 4 times 1 over 1 plus 4 plus 3 over 1 minus 1. Sounds like a problem. 15 over 1 squared plus 3 times 1 minus 4. And I get 15 over 0. Okay, that means that this one is extraneous. So 1 is extraneous. Okay, so you would need to show that that's extraneous, and then you can just box off the one solution that is actually a solution. So x is equal to negative 3/4 is a solution. Okay. Alright, so 5, 9, and 15. Okay, we are going to have more, so there's not going to be a spot to upload. You still have like 7, 8 minutes left in class, so if you want to work on them now, you can. But once we do the whole section, you'll upload it all together.